you can ask me about your project or what the subject matter. But until then, I'm just going to run through this actual exercise that we did. This is actually a big project. It was actually commissioned. We were, I guess, given fairly large amount of money, not that large, but decent amount of money to do this kind of analysis on capital market linkage, meaning that well, you know about stocks and bonds, right? Well, technically, stocks and bonds belong to different markets. Okay, stock is where you buy share for companies. Bond is where you buy bond, which could be issued by companies. It could also be issued by government. So it's kind of IOUs. And in the stock market, that could be two different markets. In Thailand, we have the SAT, which is the Stock Exchange of Thailand, for large capitalized company, public company. Then you have MAI, which is sort of like a small SME-ish. It's not SME, it's not that small, but it's not a large corporate. It's sort of like a medium-sized corporate. So technically, there are two different markets. Okay. Same with fixed income, right? Fixed income, bond market. You can have bond issued by companies. That's one market. You can have bond issued by government. That's another market, right? A bond that's issued by company can be separated into maybe investment grade and all kind of stuff. So technically, you can have different markets that are literally different market, like different platform, different market, physical location. In the old days, they actually have physical location, or you can have different market in the sense that it's traded in the same place, but you are considered two different groups. Okay, so MAI and SCT, they're both managed by the same kind of people, but they're different people. They consider different market. So those are markets. Then there's also things like FX market. FX market, there's no physical trading place. It's just what's called OTC. Okay, over the counter. In the old days, that means you actually have counters, but now you just have electronics connection. Anyway, so those are the linkage, and those are the market. Traditionally, all the economics and macroeconomics and financial research focus on one market. Okay, so we were commissioned to look at how markets will link together. The common component being Thai. In other words, Thai FX market, Thai fixed income, Thai equity, and so forth. Okay. Now this could be anything. We could even have Thai commodities market. We didn't have it here because it's not of that much interest to the sponsor. So we were looking at Thai market. Okay. Now, even though there are many Thai markets, we consider this one data set. Why? Because we're focusing on the linkage. So that's one graph data set. Okay, so right away, this is not tabular data, although we could look at individual market like volumes and whatnot. Anyway, we focus on graph data. Okay. So right away, this is chapter 7 kind of material, right? This is a many to one, meaning for the same data set, we look at it from many perspectives. Okay. We actually use, the three classes, neural network kind of model, statistical method, and also like time series econometrics. Okay. So that's why it's called multi-paradigm analysis of Thai capital market linkages. What we did was we had one little paper that focused on this, one on this, one on this, and this is kind of like a long paper. So if you go to paper with codes, paper with codes, by the way, is where I get a lot of algorithmic recipe. Okay, so there's a paper, but there's also implementation codes. Okay, that's what paper with code is. Okay, a lot of time the paper is published maybe in a conference. Usually it's not journal because journal takes a long time, and paper with code is for very active, sort of like latest month. Yeah, so we publish individual paper as well as this kind of massive combination of papers. So this is kind of like one. Basically, this is to give the sponsor of my project the whole finding. Okay, but the idea here is one data set, but look at it from many perspectives. Okay, so I'm going to skip a lot of this, but I'll show you where the data analytics appear. Okay, forget the text. I'm just going to go very quickly to tables. Okay, so these are all the, say, 14 variables they consider, market. Basically, there are 12 markets I consider: fixed income, FX, all kind of stuff. Now, okay, so what's this guy? This guy would be considered visualization, right? Because I'm not doing anything here. Okay, well, I did a little bit. Here, you don't have to worry about it. One is FX, one is SET or whatever. This is kind of like pairwise scatter plot. So right away, you can see that, say, this market and this market are pretty much independent, because when you look at their scatter plot, there's no pattern. Whereas this has a strong, maybe positive correlation, this has negative correlation, and so forth, right? On the diagonal, this, you can zoom in out, obviously. Diagonal, you can look at individual market, the distribution. What you should get from this is that it's not normally distributed. It's what's called peaky, very peaky and very heavy tail. And these are kind of like numerical correlation, so to speak. So you can look at this. Okay, so these are all the statistics and this is the visualization. Fine. Now, first thing first. I kind of did, remember, I was telling you that you can find the, say, gamma distribution and fit the parameter, or you can ask Mathematica to find distribution, and it may come up with some really weird distribution, so that's not good. What I did in practice here is actually ask Mathematica to do fine distribution within collection of family that I'm comfortable representing. Okay, so it's going to do general search, but it's not going to come up with some really weird distribution that I can't explain to my client, or so I basically narrow down to a 6 or 7 distribution that financial professionals understand, and I search over that. So this is one of those examples. Okay, set that stock exchange of Thailand. Turns out, for this data set anyway, has Laplace distribution. Now, Laplace distribution is a weird distribution to you, but if you're a financial professional, it's not that weird. It's still strange, but it's not that strange. You have student T distribution. These MBAs know this, so I'm okay with that. Now, for this, it's more academic, so I allow really some weird distribution, like Cauchy distribution. Okay? Because it's academic, but I can force this. I can say, search within just normal student T and logistic or something like that. Okay. But anyway, so these are the thing. You'll notice that there are actually 2 cases where mixture distribution comes in. So one Cauchy distribution is not good enough. You actually need 2 Cauchy distribution. What market is that? It's called zero short, which is a short term for zero interest rate, not zero interest rate, zero coupon interest rate, short end. Does that make any sense here? Okay, well, I'll just give you this sort of like, it's nothing to do with data analytics, but I guess knowledge. If you buy bonds, right? Usually it would say something like 10 years, 5% bond. Okay, that means you give it 1,000 baht. Okay, at the end of the year, they give you 50 baht. They do this for 10 years and they give you the principal back. Actually, they can give you every 6 months, 25 baht. Yes, because semi-annual. So that's when you give this money, okay, when you give this money, you get intermediate coupon every 6 months or every year, and then you get the final. So this is kind of like traditional way of investing, okay? This is how traditional borrowing looks like. Somebody takes a big chunk of money, give you coupon interest rate during every 6 months or 1 year, and at the end of the period, 10 years, 20 years, 30 years, give you the whole chunk back. Well, it turns out that in financial engineering, they say, hey, this is kind of like weird. It's like I order fish and I get the head and the tail and the body, okay? But now I'm a sophisticated eater. I just want the fish head. You can do that, right? You can go to a Japanese restaurant and say, I want the fish head. I want fish body. Well, in financial market, they do that. So based on this bond that has coupon and principal payment, they kind of like separate the meat and the head and all that. So you can actually invest in pure coupon. So in other words, I give 1,000 baht, I don't get anything in the end and just get a whole bunch of coupon. That will be considered annuity. Okay, annuity. They call it annuity because, you know, traditionally they give you money every year, but they can do 6 months as well. Then they separate the other part called zero coupon, which means that you give 1,000 baht, you get nothing for 10 years, then you get 1,000 plus accrued interest. That's called zero coupon. Okay. Well, in a financial once the bonds are issued in the market, financial engineers, what they call this strip, they strip the coupon from the principal and trade them in different markets. So in Thailand, you know, it's very sophisticated financial market. You can actually invest in a pure principal investment. So that's where the zero coupon comes in. Okay. There's also a variable called bond flow. Okay. So in this case, SET, that's equity market, MAI, that's also equity market, zero short, again, zero coupon bond, short end. So short end would be something like borrowing for a month up to a year. Okay. In fact, you can actually borrow overnight. The financial market works like that. Okay. So short end, long could be, you know, longer, 10 years. And then you have corporate bond. That means, so zero short and zero long may be 2 categories. So I can have zero from 0 to 5 years, say, whatever. I don't remember. I think it's 0 to 2 years. But zero here in this case are stripped from government bond. So this represents return of an economy based on how much or how the government borrows from you. Now, because the government of Thailand has no credit risk, right? This is considered risk-free. Now, it has inflation risk, but it doesn't have credit risk. If you have credit risk, then you go to corporate bond. Okay. Then you have Thai baht. Thai baht, that's FX. Equity flow and bond flow. These are 2 additional variables that I introduced because it was very important and considered, you know, informative for the sponsor of this project too, I think. So I added it for that. But then you have emerging Asia equity. Emerging Asia equity means it includes Thailand as a component. Okay, then you have SP500. SP500 has no Thailand as a component, but if you are in equity trading, you will know that if they have a bad day in S&P 500, chances are you're not going to have a very good day in Thai. Okay, this is because there's that kind of leading. And then also you have emerging market bond, EM bond, US bond. Now, informationally, you can argue that, and you don't have to believe me, but this is the conventional wisdom. Conventional wisdom is that what happened in the United States leads the world, and then what happens to the world leads a region, Asia, and then that goes to Thailand. Okay, so the direction of information flow, as it were, but that's not always the case. And this is the study to do that. So you look at USD. Now, USD here in case it's not dollar, against Thai baht. It's dollar against a basket of currency. So euro, Japanese yen, British pound, and so forth. So anyway, these are considered different markets. Now, I'm not looking at individual return, but I can look at the return of the market. How do I look at the return of a market? Well, if this market has two stocks, two companies, and one company is twice as big, okay, as the other, then I can put away 2-to-1 weighting of the return from stock A versus stock B, and that becomes a composite market return. Okay, so you don't have to worry about it. All you have to care is that there are actually 12, 14 variables. Each of them has unique variance distribution as found by fitted distribution. Okay. So right away, this is a statistical modeling. By the way, again, you can interrupt me and ask me about, I don't know, your project, whatever, but I'm just going to give you a rundown to show you how it works in real life. And, you know, there's as a part of deliverable, this is kind of like interactive, so you can look at any market. So notice most of them is kind of peaky. That distribution I told you, Laplace and Cauchy, that you think is kind of weird. A less weird version is called logistic, but that's also peaky. What does peaky mean? Okay, normal distribution looks like this, right? So sometimes market wins, sometimes you lose, and there's a whole bunch here. Peaky looks like this. Meaning most of the time there's no movement. A lot of time market just kind of stays still. Goes a little bit, down a little bit. But then when it moves, it goes really big. That's what makes life miserable in financial market. It's very difficult to deal in that. Okay? If it's normal distribution, as a classical financial theory say, life would be easy. But life is not easy. Life is not easy because most of the time, the market is kind of like not doing much. But when it does, it goes really far. Okay? Now, it goes far in both directions, positive and negative. That's why you can always get this investment expert who say, oh, I made a killing in 2017 first quarter. Okay? That's fine. And, you know, maybe get a YouTube likes for that. But you probably don't realize that the same guy probably lost some money in December 2015 or something, okay? So you can always cherry pick period where you make a lot of killings. Anyway, that happens. Okay. So, now this is actually a marginal fit. Okay, I call it marginal, but you don't have to worry about it. It's made individual fit. But you can also fit using histogram. So this is called empirical marginal, meaning I don't have to use a name brand like, you know, Cauchy, Laplace, normal distribution. Basically, I take a histogram, I draw a line that looks like a smooth histogram, and I use that as my model. Okay, so it's not a real model. Why do I do that? Because I don't care about individual market. I care about linkage. Okay. So sometimes I use that. Fine, go. Talk a little about coding in Mathematica and Python, blah, blah, blah. Okay, these are non-parametric statistics. I'm not going to bore you with that. Okay, this is where it becomes interesting. You guys remember about dolphins that hang out together, right? What if that hangout is not a yes or no, but it's sort of like a weighted, right? You can say something like dolphins has probability of appearing together. Okay, so that's a positive number between 0 and 1, right? So you can think of correlation as a linkage. Okay, except instead of linkage between dolphins, I have linkage between government bond and FX, right? The difference here is that the linkage can go the other way around. For example, one of the things you might know is that stock and bond usually go the other way. So it's not like dolphin where they either appear together or they don't appear together. This is actually a negatively. Okay, so something like when you see this dolphin, this guy is way over there. Same thing here. Usually when stock market is making money, the bond market is losing money. So it becomes a negative. So this connectivity, again, is represented as a graph. Okay. Now, you will notice that I also draw adjacency matrix. Okay. Now, you can say something like strongly correlated. I don't care. As long as correlation is greater than 0.5 or worse than minus 0.5, I make it a connection. In which case, I can plot this. So it's going to look what? It's going to look like this. So this is what happened? Why is it blurry? I don't know why it's blurry. Okay. So this is actually, visually, I can ask you, is this symmetric? Yes. Okay. Because I happen to use something like Kendall measure of correlation. That is symmetric. Okay, symmetric. So Spearman, you don't have to worry about it, what it means. Now, then I can do something like this. Okay. I can do something like this. Say, wait a minute, correlation between two markets, that's symmetric, right? Symmetric, right? What if I lag one market? So I make correlation between FX market yesterday versus equity market today. Then I break the symmetry. Why would that make sense in a financial market? Because you can think of information flowing from something that happens to, think of it, let's say US stock market and Thai stock market. What happened to US market yesterday affect Thai market today. So that's lagging US. Conversely, I can lag Thai, right? I can say Thai market yesterday versus US market today. Now, in the future, who knows? Maybe Thai market will actually be a leading indicator of the world. I don't know. Okay. So right away, from undirected graph correlation, Thai market, US market, now I have possibility of Thai leading to US and US leading to Thai. So now I have asymmetric, right? So it's in a directed graph. So there it is. Yeah. Right? So needless to say, once I have this graph, I can jump and do something else. What can I do? Well, I can do a community plot, but in this example, what I did was I did centrality analysis. So that if I was monitoring the market, okay, let's say I'm monitoring the market, I'm a what's called global, there's such thing as a global desk in financial market, you have to know. But I look at every variable, look at every market. But there are actually not just 12, actually there's a lot more than this. And I want to say, what's basically my attention getter? What market should I pay attention to? It would make sense, right? That the market that has important correlational linkage. So I create this linkage as a matrix, adjacency matrix. I throw this through centrality analysis. Then I rank centrality score. Then I say, these are the market. These are the things I want to look at. Okay, now solution, I don't remember, you know, that this is, I guess, relatively old data. So you can run this again and maybe get some different picture. So that's that. I'm going to skip Copula. That's a little bit more tricky than yeah, but anyway, it's another kind of link. So I can have graph between market. I can have that graph being 0 and 1. I can have that graph being continuous number. I can have that graph between continuous number between -1 and +1, let's say. Okay. And I can do centrality analysis. This is a little bit more advanced. I'm going to skip this. This is called Vine Copula. Yeah. Picture I want to show. Yeah, so this is kind of like matrix, but different correlation, different causation, and get to the point where, okay, I can take all the centrality and literally, because centrality is it's not just one way, right? There's page rank, there's betweenness and all kind of stuff. I can literally look at this and I can do radial axis plot. What's happening here is that based on betweenness, now this is radial axis plot. I'm not using clustering anything here. I'm just using it to display. The result shows that emerging market bonds are very important. So if you're going to monitor something, monitor emerging market bond and SP 500 based on this criteria. So the criteria of how markets are connected by information, by correlation, by what, based on that, these are the market to monitor. Now, based on different things, I actually have to monitor this thing. So this is different criteria. This project was sort of like created for a capital market development fund. So which metric matters to you depends on the whole professional industry. Okay, so I'm not recommending you use this measure. I'm saying these are the tools that you can use to monitor what matters to you. Okay, and for some guy, maybe monitor bond flow, equity flow, and so forth. So right away, you see two things. You see the graph. The connection is not dolphin, but connection is based on statistic. So statistic come first. Statistic create graph data. Graph data gets fed into unsupervised learning in the form of centrality analysis. And this becomes something that, you know, people in financial professional can use to inform their thing. This is more than you need. This is kind of like get to the optimization. So I think I'm going to skip this. Yeah, I'm going to skip this. Okay. So anyway, there's a lot more detail. There's even graph embedding. Now, the last word I'm going to give is this. Remember that community plot? Remember that community plot, community graph plot? That is just one of the way. The breakthrough in what's called graph neural network that's happening right now and, you know, been booming in the past 2-3 years. It's basically that kind of thing, but more sophisticated, a lot more sophisticated. So imagine, now let's go back to that picture, if you like. What happened to my dolphin? What if you don't just want to make clustering of dolphins? Where am I? Where's my dolphin? Ah, okay, this is my dolphin. Oops, no, that's not my dolphin either. Okay, this is my dolphin. My dolphin, where's my dolphin? Okay, let's say that's my dolphin. Okay. Yeah. This is unsupervised learning. Okay. Now imagine this. With large language model, you can predict words, right? You can predict words based on closeness. Okay. So imagine, okay, word for large language model, you put words in some kind of context closeness. So you can predict if the person say, I've been having such a bad day, right? Nobody ever say, I've been having such a bad chocolate. It doesn't work. Okay. So that proximity is very important. So large language model basically put words in proximity space. That's what it does. Okay. Now imagine that proximity space is defined by graph. Okay. And obviously, a simple, naive, very naive application would be, if this is my dolphin, where's my dolphin? Okay. If my dolphin here, the red dolphin, likes to eat tuna. Okay, chances are, for example, if TR88 likes to eat tuna, and TR88 hangs around with fork white tip, chances are if I want to see fork white tip, I'll probably bait with tuna. Okay, just based on closeness, right? I know that Oscar likes clam. Dolphin eats clam. Yeah, I think so. I think dolphin eats clam. So if I want to find notch, I would probably go to where the clams are. Okay, what does that mean? What is the sophistication? It's the unsupervised learning. All right? But what is completely naive? That supervised learning problem, right? Prediction. Okay? Based on how close Notch is to Oscar, I predict Notch taste in fish versus clam by asking Oscar, which is his best friend. Because if dolphins hang together, they probably eat together, right? Guys who hang together, they drink the same kind of drink, whatever. That's what I think, right? So now imagine that instead of clustering for its own sake, who hangs out with who? What if I give it another job? And that job is not only do I want to cluster the dolphin, I want to make sure that I can predict the taste in fish versus clam versus shrimp versus whatever based on clustering alone. So it may turn out that based on that supervised learning task, this clustering is not good. This kind of location is not good. Maybe something else is better. So this is very sophisticated. It's mixing unsupervised learning with supervised learning. Basically, that's what things like ChatGPT does. It's doing this quote unquote placement of word into a vector space that are close by context, but not only close in the context, but close in the context with good predictive power. See what I mean? Okay. So I'm having such a good day or bad day. Well, day is very close in context to month, week, right? Good is also close in context to happy, whatever. Okay. But the fact that not only do you have words like good together, but somehow if I have this concept of having such a bad, immediately I would go to day. So that's kind of like taking this kind of closeness to the next level. It's not only placing words that are similar together, but so that you can do this kind of prediction with it. Now, a simple thing that I want you to keep in mind, and I tell you, it's a lot more sophisticated than this, is to think of the thing called word algebra. And you may have heard this before. I have the word king. That word king is placed somewhere in this vector space. By the way, that vector space has dimension 300. Usually that's the minimum you need. So imagine x1, x2, x3, x4, x5, x300. There's a space of x300, real number. The word king lives in there somewhere. Okay? Now, you can take the word king, take all the values, subtract the value from the word male. Add the values from the word female. You get 300 number. And if you go look in that space of 300 numbers, you will find the nearest word to it is queen. See? So it's not closeness like, position in society or sex, but you see what I mean? To have this kind of sophistication so that you can do word algebra, king minus male plus female equal queen. Right? boy band minus boy plus girl plus Korean. Maybe you get a Korean girl band, right? Or I think maybe like, I don't know, when I was not young, but when I was younger, boy band, girl band, this was English concept, right? So you get something like a Spice Girl, right? Spice Girl minus girl plus Korean. Then you get a boy band Korean. Okay? How would that work? Is the sophistication comes from placing the word boy, the word band, the word Korean in the 300 dimension, such that you take the word Spice Girl, find it in the 300 dimensional space, find the word girl in the 300 dimensional space, minus it, take the word boy from a 300 dimensional space, plus the word Korean in the 300 dimensional space, and then find the nearest word to that, and then you will come with what, I don't know, B2S or something, or, you know, metro or underground or something. Okay, so that sort of thing. Now, except that is algebra. Imagine that instead of doing this, you say something like, I can predict the happiness of a Korean by looking at happiness value of everything else. So it's even more advanced. Okay, so word embedding, the closeness, the distance is usually in terms of context. Do the same thing with graph, and then you have what's called graph neural network, graph embedding, or geometric deep learning. That's all I'm going to say, because graph neural network, geometric deep learning, graph embedding is a very advanced topic even for me. And you should find this in a machine learning class. I love graph. You know, obviously, I told you I was one of the first guys who did centrality analysis. I also love neural network, but the combination of graph and neural network only became a thing in the last, I'm going to put down 2019. Yeah, 2019. If you go before that, yes, you see some paper, but it hasn't blown up. So let's say the blow up year for graph neural network, I would say, well, 2020, just have a round number. Okay, 2020. So 2010 is the blow up period of convolutional neural network, detecting picture, cats and dogs, right? 2020 is the blow up of graph neural network and large language model. Okay, but you know, that's way beyond this class already. Okay. So anybody wants to ask a question? Let me see how we're doing on time. Oh, my bad. You know what I should do is have a big clock, but it's too late for you guys. Sometimes they have, you know, on this hackathon, they have these big numbers, and I never look at time. Okay, so fine. That's it. I hope you've gained a lot from this class. As you realize, even though there's a core to it, right? Supervised learning, unsupervised learning, tabular data, statistical model, visualization. These are sort of like things that have been part of this class since 3-4 years ago. But if you go watch the video of this class 4 years ago, you will not hear the mention of graph learning. Okay, you might hear a little bit, but you definitely will not hear large language model. So the content of this class is evolving. Okay, it's evolving. Okay, so okay, good luck. I will give you till I think exam week, I think it is, to handle the project. So again, you don't have to have the white paper, but a white paper would be nice. Okay. I gave you this example, right? Sorry, let's do this. Paper with code, COVID, data. I don't know. I don't remember. Yeah, somewhere in there, I think. Yeah, analysis of global, okay, so this is kind of white paper. I don't expect you to produce that, but it's good idea to read that because it describes the methodology and that sort of thing. It would be nice if you can do that, but don't worry. But definitely presentation, right? Presentation, and that's the presentation that goes to deep dive to methodology. And then the 3-minute video, you obviously just kind of mention. You can't do much. Okay. So let's do the same format, 20 minutes. It would be better for all of you to present and I go back and give feedback. But I found that, in practice, it's probably easier for me to just give feedback right away. Okay. So let's do that 20. So your presentation should be 15 minutes. I'll just only make my comment really brief because back then I'm not giving you any feedback. I'm actually grading it. Okay. So 15 plus 5, 15 plus 5, 15 plus 5, 15 plus 5 for everyone. And then your video should be 3 to 5. Don't make it longer than that. Okay. And the exam, again, I've given you plenty of hints as to what function I expect you to know to do on the spot. Okay. Same deal. You will be entering your student ID, and that will randomize the data so everybody gets a slightly different thing, and then choose your probability distribution, blah blah blah. Okay, good luck. Yeah, sorry for running a little bit over, but hey,